Assalamu alaikum, dear students. Welcome to the lecture of the electronics. In this lecture, we will discuss about the operational amplifier as inverting. How operational amplifier invert the input signals and what are on what factor its output depend. So let's see. We have a diagram of inverting amplifier circuit in which R1 we have a resistant R1 as input in which we have to give input and this is the inverting terminal of the amplifier. This is the inverting terminal in which we have to give some inputs and this is our outputs uh, output terminal and this is resistor through which we want to extract output of the amplifier, and here we will give some inputs. Let's see that this is our input and this is our non-inverting terminal which we need to be ground. So potential of this will be 0 because this is grounded, and through this we will give some inputs, and so this is our output. So if we look back to any diagram, this looks like this one. This is our input resistance and this is our input, the input given to the resistance 1, and this is output resistance which is RF, and the non-inverting terminal is grounded. So let's see to find the input what is the relation between the output and input. As you know that input is given to inverting in terminal, so output will be inverted. Output will be inverted. In what sense output will be inverted? Mean if we give input like this, so there will be 180 out of change. So this input will be amplified as well as inverting. So let's see how this invert the input signal. This is our input and this is output. This does the two jobs. The first thing is that it amplifies the signals. This operational amplifier will amplify the signal and it will invert the input signal. So current entering to the circuit. The first is current entering to the circuit. Current entering to circuit. Current input to circuit will be equal to, for example, let this is the current which enter to circuit is I1, and current leaving to circuit is I2. So I1 will be equal to potential difference divided by resistance. So potential difference is just like what is the potential difference? The potential difference is this potential difference between this point and potential difference between these. We have to take into account the potential difference of these 2 points, which will be just like, if I rearrange this page, so it will be like I1 potential difference is equal to this V input minus V minus divided by R1. Okay, potential difference is V input minus V minus. So this is actually potential difference of these 2 points. This one minus this is the potential difference divided by this resistance. You know that V minus from the previous you know that output loop gain is equal to V output over V plus minus V minus, and which we assume that V plus and V minus have equal inputs, V plus minus V minus is equal to 0, because this was maximum, so this should be minimum. And in that case we have V plus is equal to V minus, because this term should be minimum, and the minimum value of this is 0. So V plus is equal to V minus, which is equal to 0, because V plus, we know that V plus is grounded, so potential is 0, and which is equal to V minus. So V input minus V minus is V plus, and V plus is equal to 0 over R1. So it will be equal to V input divided by R1. This is the current entering to circuit. Now current leaving to circuit. Current leaving out of circuit. Leaving out of circuit. What is the current leaving? That will be I2 is equal to potential difference divided by R2. Potential difference divided by R2. So what is the potential difference? Potential difference between output, this potential difference between this point and potential and this. So we have to take the find the potential difference of these 2 points, this point and this one. So potential difference will be equal to V minus minus V output divided by R2. And you know that V minus is equal to V plus, and which is equal to 0. So this will be equal to 0 minus V output over R2, and this is equal to minus V out over R2. So according to Kirchhoff first law, the current entering to the circuit should be equal to current leaving to the circuit. So we can say that current entering should be equal to current leaving through the circuit. So if insert another page, according to Kirchhoff first law, which is equal to current entering to circuit is equal to current leaving to circuit. Leaving to circuit. Leaving out of circuit. So current entering to circuit was I1, and current leaving to circuit out of circuit will be R2. We have really found that current entering was V input divided by R1, and current leaving was minus V out over R2. So the ratio of output over input will be equal to minus R2 over R1. So ratio of output over input, this is just like an amplification factor. What is the relation between the output and the input? And this is equal to minus, this minus sign, the output voltage will be inverted. The output or input the ratio has inverse this minus sign. This means both have opposite sign. Output and ratio of output voltage and input voltage has inverted, and this depend upon the ratio of resistance 2 and resistance 1. It does not depend upon the internal structure of the operational amplifier. So output is equal to minus time of V input multiplied by R2 over R1. So our output will be amplified if we kept higher resistance of R2 and lower resistance R1. So our output will be amplified, and this negative sign shows that it will be inverted as well. So we can see that Here, in this case, this input will be inverted as well as amplified, because in our case we have a negative sign, and this will be and this output does not depend upon the internal structure of this whole setup. Okay, so I will stop at this point.